I welcome you to this MOOC course. I'm going to start my first topic, introduction. So now why voltammetric study is important. Actually, we know in a few decades ago, the lead poisoning in children that may cause inoxaria, vomiting, convulsion, permanent brain damage. But why this lead get entered into drinking water? Because they are using this normally tanks which are welded with that is joined by copper pipes and tubes. So in that particular building there is a small percentage of lead, and through this the lead enters in drinking water, and due to this the lead poisoning in children causes. Now what are the different ways to estimate this particular poisoning? Because this might be in per million level. So to estimate this under extreme voltammetry is one of the most sensitive method, because by using this we can measure the few parts per billions of lead. So voltammetric study is now very much important. So this voltammetry term referred to the group of electroanalytical methods in which we get the information of analyte by measuring current in an electrochemical cell as a function of applied potential. So we are varying the potential and we are measuring the current, but these are obtained under certain conditions to promote the polarization at working electrodes. So different types of working electrodes are normally used in voltammetry techniques. In later topic we are going to see what are the different types of working electrodes that are used. Now when the current is proportional to analyte concentration, it is monitored as a fixed potential. So this particular technique is termed as a amperometry. Now to enhance the polarization, so working electrodes in voltammetry and amperometry have surface areas of few square millimeters. So these are sort of micro electrodes, and in some applications a few square micrometer or less. So these are having very important applications. So micro electrodes are required to success in voltammetry techniques. Voltammetry is widely used by inorganic, physical and biological chemists for fundamental studies of oxidation, reduction processes in various media, adsorption process on surfaces, and electron transfer mechanisms at chemically modified electrode surfaces. So actually in voltammetry the current which get developed in electrochemical cell is measured under the condition of complete concentration polarization. So what is exactly mean by polarization? A polarized electrode is one which we have applied voltage in excess of that predicted by the Nernst equation to cause oxidation or reduction. In contrast, in potentiometry techniques, the measurements are made at a current that approach zero and where the polarization is absent, that is galvanometer shows null deflection, and then at this particular point we are measuring the potential. So potentiometry techniques is quite different from voltammetry techniques. Again, this voltammetry techniques is different from coulometry techniques in that which coulometry measures are taken to minimize or compensate effect of concentration polarization. So readings are taken when the concentration of polarization minimizes, and furthermore in voltammetry there is minimal or no consumption of analyte, while in coulometry essentially all of the analyte is converted to another state. So it is efficiency regarding when we are having very less amount of analyte. So preferentially voltammetry techniques are preferred. So in we are going to summarize this particular point. So voltammetry is nothing but electrochemistry techniques based on current measurement as a function of applied voltage, and the requirement is to achieve the complete polarization. This can be achieved by using small surface area electrode. So these are useful to study, as we already discussed, oxidation reduction process in various media, adsorption process on surfaces, and electron transfer mechanism at chemically modified electrode surfaces. So while looking towards the history how this voltammetry technique gets developed, so going back towards in 1922 the polargraph, the scientist Jaworski who developed the polargraph, that is which recorded the current voltage curve for a solution of 1 mole or NaOH. So this particular technique is termed as a polarography, although it is quite different from voltammetry, but this discovery of these techniques leads to the development of voltammetric field. So Hevosky correctly interpreted the current increases between -1.9 and 2 volt, -2 volt as being due to deposition of inequal ions forming an amalgam. So amalgam is nothing but whenever the metal, it is the solution of metal in mercury. So for his ultimate discovery, he received the Nobel Prize in Stockholm on 10/12/1959. But while polarography has declined in importance in voltammetry and amperometry at working electrodes other than the dropping mercury electrodes have grown at an astonishing pace. Voltammetry and amperometry are now the very much important tools nowadays because various electrodes where we can use in voltammetry apart from dropping mercury electrodes. Furthermore, voltammetry and amperometry coupled with LC have become powerful tool for analysis of complex mixture, and modern voltammetry also continues to be an excellent tool in diverse areas of chemistry, biochemistry, material science and engineering and the environmental sciences for studying oxidation reduction. So there are different types of voltammetry techniques. So polarography, which one is basic one, then linear sweep and cyclic voltammetry, hydrodynamic voltammetry, pulse method, AC voltammetry, then also stripping method. So all these are different techniques which can be effectively used in analytical chemistry. So among these, the one basic term which we are going to see, that is excitation signal. So we are seeing 4 different types of signal here. The first one is linear scan, second one is differential pulse, third one is square wave pulse, and fourth one is triangular pulse. So excitation signal is nothing but the current in the cell is recorded as a function of time and thus as a function of the applied voltage. So this is nothing but the relationship between potential and time, and this one is termed as the excitation signal. In amperometry, the current is recorded as a fixed applied voltage. So whenever the linear linear scale is obtained, it is the type of voltammetry is polarography and hydrodynamic voltammetry. The figure B and C, these are the different types of pulse voltammetry techniques. That is the voltage is recorded at the end of the pulse, and the last one is triangular shape. This one is normally observed in cyclic voltammetry technique. That is voltage first started at one point, it goes at the other end and came back to original voltage position. So this particular triangular shape is obtained. So these are excitation signal. So here we end our first topic. We will continue actual instrumentation in the next topic. Thank you.